Hello everybody, I'm Lingli Zhu from National Land Survey of Finland, and I received my PhD from Aalto University in 2015, and my knowledge was in the field of photogrammetry, LiDAR, and topographic database. So currently I'm leading the Autumn project in map production. So today I'm going to talk about the use of Shore for ArcGIS and ArcGIS Pro for the Autumn project. So today's topic will focus on Esri products for our Autumn project. First of all, I will introduce the Autumn project to you. Autumn means Advanced Technology for National Topographic Map Updating. Secondly, I will talk about the use of Shore software in our project. And after that, I will introduce the ArcGIS Pro 3D analyst extension and its use in the Autumn project. So in the last part, I will talk about our next move in using the ArcGIS Pro. Now, let me introduce the Autumn project. Why did we need this project? First of all, in National Land Survey of Finland, topographic map was updated by stereo models of area images with many operators. It's labor intensity work. Secondly, the new area imagery program started in 2020. So there are a huge number of area images acquired every year, so covering 1/3 of areas in Finland. So the left image shows the new area image production areas in 2020. One of the applications is to be used for topographic map updating. So also the new national LiDAR program started in 2020. So new LiDAR data yearly covering 1/6 of areas in Finland to provide accurate point cloud data. The last point was that in recent years, AI has been used in more and more geospatial applications. The Autumn project is a 2-year project starting from January of 2021 to the end of this year. So it was funded by Ministry of Finance in Finland, and the scopes of the project are to find methods to reduce the amount of manual and routine work in GIS production and improve the accuracy and up-to-dateness of spatial data. So we developed deep learning solutions for national topographic map updating. So we focused on buildings and the roads updating and the hydrographic feature detection. So the right figure shows the deep learning framework, input the training data, train a model and the neural network, and output the results. Here is the overview of the tasks in the Autumn project and also presenting the role of Esri products in the project. So we can see the dark blue circles. One is the Shore for ArcGIS for producing true Orthophotos and DSMs, and another is the ArcGIS Pro in post-processing. So let's have a look at the Shore for ArcGIS. And the installation of Shore software requires a minimum of 64 GB RAM and the recommended 128 GB RAM. And the Shore uses more memory dynamically to improve performance. So this software was built based on the algorithms of photogrammetry and computer vision. The process is based on area images or take advantage of a combination of area images and the LiDAR data. So the software can produce just referenced true Orthophotos, DSMs, point clouds, and meshes. In the Autumn project, The Sure software was installed in the CSC high performance environment. It produces true orthophotos, DSMs, and the photogrammetry point cloud. So we are aiming for producing the training data for neural networks by the Sure software. Thus, we focused on true orthophotos and the DSMs. Meshes were not used in our project. As we know that Orthophoto is one of the national topographic products covering the whole Finland, and it's open data. And why do we still need the true orthophotos? So let me explain it. The difference between orthophoto and the true orthophoto is that true orthophoto are produced from area images and the digital surface models. Orthophotos are produced by area images and the digital elevation models. So the upright figure shows the difference between the digital elevation model and the digital surface model. So digital elevation model consists of ground points, and the digital surface model is the point collection of the top of objects such as the roof points, the points on top of trees, and so on. The image geometry between true orthophoto and orthophotos is different. True orthophoto has an orthogonal projection with a uniform scale. One orthophoto has a perspective projection with non-uniform scale. So the main effects are the buildings. So true orthophotos remove the building tilting. So this is a true orthophoto. Because of orthogonal projection, you can only see the building roofs, but not the walls. This figure shows the orthophotos from different years. Left image was from 2015, and the right image was from 2020. So from both images, building walls are visible. Also, the image projection from the different years are different. It was affected by area camera shooting directions. So building locations might not be unique from the different years' orthophotos. However, on true orthophotos, building location does not vary from the different years' products. Here is the example of digitizing building vectors from the true orthophoto, and we use it as a high-quality training data for our neural network. Here is the example of a digital surface model produced by the Sure software, and this image contains 3D information. Each pixel has the height information. So let's have a look at 3D analyst extension in ArcGIS Pro. So it provides tools for creating, visualizing, and analyzing GIS data in a 3D context. The GIS 3D Analyst Extension Toolbox provides a collection of processing tools that enable a wide variety of analytical data management and data conversion operations on surface models and the 3D vector data. So the Autumn project uses the ArcGIS 3D Analyst extension for building regularization. Here shows the examples of the use of 3D Analyst for the Autumn project. So in the figure, red buildings were extracted by the neural network, and the green buildings are after the process of the building regularization. So you can see that building corner in the green figure is in the right angle, and the green buildings are more visually pleasant. This is the overview of before and after building regularization. So the left one is without building regularization, and the right one had building regularization. And next, we are going to explore the ArcGIS Pro for deep learning. So ArcGIS Pro allows us to use the statistical or machine learning classification method to classify remote sensing imagery. 3 extension licenses are needed for deep learning applications: image analyst, spatial analyst, and the 3D analyst. So later, after we get experience from ArcGIS Pro for deep learning, we will also share knowledge with you. So that's all for today. So thanks. Thank you for your attention.